Hi there guys, we are back with the orthographic projection, and it's of a geometric solid. And in our previous videos we've actually shown the actual solid shape. I'm going to do the same in this video for understanding. You would have seen that you have your front view of your shape, and then we would have drawn the actual top view of the shape. We've actually drawn that top view. Flat on the surface, because obviously you'll have a flat piece of paper and you would have found your top view accordingly. Now we're going to go about the numbering system. I'm a firm believer in a numbering system because if if I have a complex drawing or shape, I can keep track of my actual shape and the necessary points via numbers in the different views. So if this would have been number 1 in my front view, then straight away I'm going to have to project number 1 down to find the actual top view. So let's go and see how we do this. Let's hide our solid object, and we are going to go ahead and project. So first of all, I want to go and give my top view numbers. There it is there. I've given my base points or my base corners numbers of 1, 2, and 3, and I've given the apex. Remember, this is the top view of my actual shape. So I'm going to be looking from the top, and I'm going to be seeing the apex as a little dot over there. Remember, I will see the lines going from the base corners to the top from 1, 2, and 3, and I'm going to be numbering that apex 0. Okay. So first things first, I'd like to go ahead and project those numbers straight up to my front view. So there you can see that number 1 is in line with number 1. That is very necessary, because if I'm looking from the front view, I would need to see that number 1 is in fact in the actual same position. Remember that if my shape moves from my top view or in my top view, it would be correct to say that my front view would also be moving at the same time, because this is the actual front view and that's the actual top view of the same shape. Alright, so if I'm moving my top view, my front view would have to move at the same time. Alright, so there you can see I've projected point 2 up, and it's in line with number 2 over there, and 3 and 0 happens to be in line over here. Therefore 3 projected up from this point here to my front view is found here. But what do we know about 0? We know that it is an apex, which is a whole lot higher. Right, it is also in line. Let's quickly fix that up. There we go. So we have 3 and 0 in line. We have 3 at the bottom. Remember, 3 is a base point or base corner, which is at the bottom of the shape. There we can see it over there, and I know that my apex is in a little bit higher situated. Okay, there it is there. Okay, so now once I've actually done that, I want to go ahead and project these numbers across to find my left side view. Okay, let's include those projection lines. First of all, there we have the height of my actual pyramid. There I will be projecting along the points from my top view to the 45-degree line. Here I'll be projecting it straight up, and remember that would have been the actual 0, the apex. Let's make them all visible so it's nice for us to see. And for a moment there you saw the left side view. Great, because we know that when we connect each one of these dots, we will actually see the shape. We have one line that is a little bit of a confusing factor over here, and it would in fact be that line over there. We do not see that line, because remember, when we are going to look at our shape, let me quickly show it. When we are looking at our solid shape from the left side view, we do not see a line running from the apex down to our base edge. Okay, this is a flat surface. We see line 1, 2, and 3. Let me turn it a little bit more. There we go. Okay, right, so that shape now needs to disappear. Let's stick to a 2D shape and not 3D shapes. Alright, now that we've put in and included in all our construction lines, we now need to add up, and we are now working with numbers. Like you've seen here, 1, 2, 3, and 0. I've projected them up to the necessary points, 1, 2, 3, and also 0. I need to find those points in my left side view. So straight away, when I'm projecting this line across over here, this line belongs to 1, 3, and 2. So what I like to do in my drawing is once I've projected this line across any length, I'm going to label that at the end of the line 1, 2, and 3. Right, so we're going to do exactly the same with 0. There it is there, the apex called 0. I'm going to be projecting that height across, and I'm also going to be labeling the end of that line 0 because that line belongs to the apex. Right, so once I've done that, I now know that I need to go and find exactly where these lines would collect, where they would connect to find the separate numbers. Now, please pay attention to number 1 and number 2 over here. I'm going to zoom in there. Number 1 and 2, when I look from the left-hand side, they will be in line with each other. So I won't really see this line over here. I'm going to be including the solid shape quickly again so we can actually make sure of our facts. There it is there. So I'm going to turn it, and you'll see there that when I look from the left hand side, that is number 1 and number 2. Let me just turn it like that. Number 1 and number 2 at the back. When I put them in line, you'll see that I have a left side view. Okay, and I'll only see one point. There it is there. Okay, so please take note that 1 and 2 is in line with each other. Alright, and there you'll see that 1 and 2, when I project that line across, they're in line with each other, and I'll project 1 and 2 up. I do not have two separate lines. I've got one line going up and across. Okay, let's get this solid shape away again. There it is. Right, now the next part of this is obviously making sure that each one of these numbers are found properly. So as we just explained, 1 and 2 will be in line. So there we go. That line over there represents number 1 and number 2. And where they then connect with the projection line from the front view for 1 and 2, that will be point or points 1 and 2. This projection line, number 1 and number 2, are also in line. You can see there. Okay, like I have labeled them as well. And where I find 1 going across and connecting with that line is the dot number 1. And where I find number 2 going across and connecting with that same line that belongs to 1 and 2, I can call that same point 2. Hence my labeling 1 and 2. Alright, let's look at number 3. Number 3, however, is a single point. It's not in line with any other point. And when I look from the left side view, I only see that one point. I've projected it across and up. And where it connects to number 3's line from the front view, there we go. We can see that 1, 2, and 3 are on the same line. Hence my labeling. I will be able to find number 3 connecting with number 3's line from our front view on that point over there. Let's look at point 0, which is now my apex. Point 0, there it is in my top view, projected across and up. You'll see that I've labeled it 0 here, but point 0 is not on the ground. It's not on the base. It's not found on the base, so I can't draw it down the bottom here. This is basically just a reference for me so that I know I can actually project it a little bit further up. And where it goes further up, you'll see that it falls on line 0 from our front view on that point over there. So I really do firmly believe in a numbering system because, you know, this is quite a simple shape, a triangle with only 3 or maybe that 4th point. But if I had a different polygon, for instance, as a hexagon or an octagon, it starts getting more complex and I need to keep track of more points. So then numbers are definitely going to play a big role. Okay, so once I've actually got those points, I can now go ahead and join those points. Now, this is exactly what we want. This is a confirmation system for us. 1 joins to 3, so with that point, or that line, sorry. So 1 also joins to number 2 with that line, and 2 joins to 3 with this line. Okay, so let's confirm that those are all base edges. They're all found at the bottom. So if I go ahead and I say, well, number 1, which is this point here, does it join to 3? Well, let's have a look. 1 does join to 3. with that line. So I can go ahead from 1 and draw a solid line right across to 3. Let's confirm that 2 and 3 actually do exist. So 2 and 3 are connected with this line over here. So I can go ahead and draw a line from 2 to 3. Okay. Now obviously from the left hand side, being first angle orthographic projection, I will see 1 and 3 and therefore know that 1 and 3 would be my solid line. If point 2 was arisen off the ground ever so slightly, then point 2 and 3 would be joined with a line in hidden detail. Okay, but in this case here, they're nice and flat. We don't have any hidden detail lines. We're simply going to be joining the lines as base edges down the bottom. Right, so let's confirm. Does 1 join to 0? Let's see. 1 to 0 joins with this line here. Correct, it does. So let's see. 1 to 0. 1 to 0 needs to be connected. So draw a line and solid over there. Number 2 and 0 is connected with a line which is in line with 1 and 0 when seen from the left side view. So it will be 0 and 2, exactly the same line. And then 3 and 0 will also be joined. So therefore 3 and 0 will also be joined. Remember, this line here is only seen because it's a projection line, so we have constructed that line. So I'm going to go ahead and take it away for our common sense sake, and we're going to go ahead and join the necessary lines to find the left side view. There we go. Alright, so let's take away the actual projections. And now I have the exact numbering system coinciding with every view. Alright, let's see, I think I've got more projection lines to take away. There we have. Okay, I don't really want to take too many numbers away, so let's just put those back. Right, there we go. So we have 1, which is in line with 1, it's at the bottom. 2, in line with 2. 3, in line with 3. 0, in line with 0. Thank you for watching, and please stay tuned for more of my videos.